Hello, Mark Biasotti. It's been a few years since I have produced one of these tips and tricks for SolidWorks videos, and with 3D Experience World coming up for 2024, I'll be doing two presentations there. I wish I could have you join me there live as I do those, but if you can't, then I want to record those sessions here and add them to this series. The first presentation that I'll be doing is the master model technique. Does it unite or divide us? And I've learned a number of things since the last time I did a webcast on this topic that I want to share with you, and hopefully you'll gain some new insight from this technique and what I've learned that I can share with you. So let's get right into it.
Well, thank you for attending this presentation today. This is a follow-on to a presentation I gave about master model a few years back, but I wanted to revisit the issue because it seems to be a controversial issue with companies and individuals, and I thought it would be worthwhile to revisit the subject and talk about what are the objections, what are the benefits, and just to gain a better understanding of its use, when or when not to use it, and ultimately to bring the subject to you to consider it to make you a more productive and efficient designer. So I'm going to get into that, but if you're here today to see a hands-on use of master model, this isn't the presentation. I have a two-part presentation on this on the Spanner website, and I'll highlight this again at the end if you want to stay around. But if there's another session you want to attend that's important to you and you were looking for a hands-on of master model, well, you might want to go to that presentation instead and check out these videos later. So I just wanted to bring that to your attention. So who am I? Well, I'm Mark. And I've been in the product design industry for more than 40 years. Really dates me, having been my first job at Atari doing consumer products or gaming systems, and moved on to HP and then IDEO. I spent about 16 years there, and then I was a product manager and product definition specialist and manager with SolidWorks for almost 10 years. And then got back into product design at Spanner, and then went off to Sarcos to fulfill my passion for robotics and animatronics. So that was a lot of fun. Some of the companies I've worked with over the years here, Fortune 500 companies, been privileged to do or be involved in some of their designs. It's been fun. So enough about me. So let's talk about master model. And so you're definitely familiar, I'm assuming most of you are familiar with parametric history-based design. So that is building up a part in your tree and then making associativity to parent and child features and easily changing a parameter and having everything update. Well, that's the beauty of SolidWorks. Master model, if you're not familiar with it, is an extension of that. It's an extension of that outside the SolidWorks part. So the idea is that just as features drive other features within a part, a master model drives a file or files outside of the part. So you can create a master file, as is illustrated here in this boombox. You can design the intent of it. That is the exterior, all the exterior features usually. And then because of manufacturing, you can't manufacture that as one piece, or at least manufacture it and assemble it. So you need to divide it up into its various parts for manufacturing. And that's where master model comes into play. So you've identified the design intent, that is the exterior shape, and then you divide it up into its parts for manufacturing and assembly and capture of electronics and components, as is in the case of consumer products, and you have it all reassembled into an assembly, and that becomes your product. So the beauty of that is, especially with consumer products, a lot of the part lines are not linear or not simple, and to try to create each of those parts independently from each other would be very, very difficult. So for consumer products, the master model technique is a must and has been greatly adopted for consumer products. But you might not be thinking of master model, or be thinking of it as just for consumer products. It's not. Master model can apply to many different industries, and for example, in robotics, as I had my experience at Sarcos, master model could be very valuable for designing actuators, because a lot of companies, what they'll do is they'll purchase the stator and rotor from a manufacturer, but then they'll customize everything around that for robotics. So, you know, you have your stock parts, but then you need to design various custom parts to make that a complete actuator. And master model is super valuable for that, because the associativity between that stator and rotor, as well as like the harmonic drive or a planetary gear, is really intimate. So having that all in one part file to design is really valuable and very efficient, I might add, because you're just working with a single master part file, and you don't have to be jumping around between different parts if you were to do it in an assembly and make it in context of an assembly. It's very convenient to have it in one part. I mean, imagine if you had a gear train like this one, for example, where you would, in a master part, would create a layout sketch of all the gears and their pitch diameters, and then have that single sketch or a few sketches drive your whole gear train. You could, in essence, start to experiment with different gear ratios, different RPMs, by just creating that one sketch and then starting to modify it to suit what the final outcome would be for the final RPM. So that is just super valuable. I really love master model for complex mechanisms or dynamic mechanisms, where you have something very unique, not stock as far as parts, but you're creating something that is a number of parts that want to move together to create a particular motion. And what's really valuable about master model is that you can do that in a single part file. And then the idea is that once you derive those parts out using save bodies or insert part, those parts become immune from their associativity. That is, you're disassociating the association of those parts to each other from motion. So once you derive them out, create it into an assembly, then you can apply motion mates to that and do everything you want to do, but still maintain the design intent of the original parts. So I love to use it for that. So let's talk about the disadvantages and objections to master models. So we'll start out with the bad and get to the good. So the objections I've found in my experience working in the industry, there's a few reasons for that. The first that usually comes up, well, it's too complex and I don't want to have to open another file to make my edits. I just want to work on a single part file. I've also had it where vendors don't want to support multiple part files. They just want one part, one drawing, one step file. And they're not going to bother with a lot of associative or master files. PDM systems don't play well with master models because they're not an actual SKU or part. They're something that drives other parts. So how do you track that in a PDM system? I've found that we can. In Sarcos we did. do that efficiently. So it just takes a little bit more work to figure out how to do that. So it's not a super obstacle. The other thing too, kind of goes with the first point, is that it just becomes pretty obscure when you have a part and you see a stock feature in it. You're not sure what drives, where that is, how it drives the part, it becomes a little obscure. This is especially a problem when you have multiple derived parts on each other, and I'll talk about that and not to do that. It can be dangerous if you don't include that master part in the database, or it gets deleted. Then you're kind of making your derived parts dumb parts because there's no design intent, because you've lost or deleted the master file. You don't want to do that, obviously. And then most of all, what I've found is that people try it, they don't understand it very well, and they just dismiss it because it's a disaster for them, because they maybe aren't applying good practices to it. So another thing too is it's an emotional issue, and it's psychological, and I kind of try to think about why this is, and I think the reason is because, and I'm an engineer too, as well as a product designer, engineers love control, and when they perhaps don't have that control, they object to it. This is probably a good presentation for those of you that feel that, because this is a way for you to get more intimate and better understanding of master models, so you can control it. And I think you should control it. So there's some real downsides that are, in addition to what I've already talked about. We talked about the misplace of the master model, and you just don't want to do that. If you're on a PDM system, you want to make sure that part is checked in and there's multiple revisions of it. So a master drives multiple parts, and one change in a master model can kind of inadvertently and unconsciously change multiple parts. So this is a real issue, and you need to be careful of it. If you have a master that's driving multiple parts and you want to make a change for one of those parts, it can be somewhat obscure what it's actually changing in other parts. And you just want to pay attention to that feature in the master and check all the other parts that are coming from that master model to make sure that they aren't unintentionally being changed also. So the other one, and probably the biggest one, is that if you have a large design team and you need to distribute the design the design workload amongst those people, a single master is somewhat adherent to that, because what you're doing is usually you can only have one person working on the master at a time. And if that person's working on that and has it tied up for a long time, then he's tying up everybody else's derived parts that come from that master. Or in the beginning of a project, if there's a lot of work to do on that product and a lot of it's contained in the master, it's only can be controlled or designed or modified by one person at a time. And so I find this to be probably one of the biggest issues with master model is the distribution of the workload. So we've talked about the disadvantages. Let's talk about the advantages of master model. And I'm hoping that for some of you, the advantages outweigh the disadvantages. So one of the biggest advantages of master model is the fact that you're reducing your work by up to 90%. If you can imagine multiple parts of a product, a lot of the features amongst those various parts are sharing their features. So, for instance, bosses that are connected to each other, those bosses are designed to be very associative to each other. If you were to design them separately and separate parts without any associativity, you're basically duplicating your work. And so there's a huge advantage to master model, that you're reducing the total number of features in your design. It's also, along with that, you're increasing the accuracy and the reduction of interference, because in the master model, if all those quote quasi parts, I call them quasi parts because they're bodies that eventually become parts, they're associative to each other. And you can clearly see that, and you can clearly design the intent with offsets and whatever in the master, so that there's never any interference, and all of the design intent is being driven from a single part file, instead of having multiple part files with their independent features that are being driven independently. And that really can easily lead to interference between parts. And also the design intent is more faithfully maintained with a master, because one master file is defining all of the design intent. And so if there's any changes that need to be made down the line in the concurrent engineering process, you can more easily and more faithfully make those changes. And then I talked about mechanisms can be conceived much more rapidly using master model technique. So we talked about the feature reduction. So here's just a kind of a diagram of that. If you were to just create parts independently of each other that fit together, well, a lot of those features would be duplicated between various parts. And so the alternative is, in master model, you create those features, but then you're driving and sharing those features amongst derived parts. And that's really the beauty, for all the reasons I talked about previously, for doing master model. It is a hierarchical process. That's why it's called master-slave. Well, it's not politically correct to call it slave these days, but that's why we call it derived. So you have a master that's always driving. It's always the master to all of its derived or child parts. And that's by design intent. You want that. You want it to be a one-way path, because you never want the derived parts affecting the master, because that would affect the other derived parts. So we talked about accuracy. The accuracy is dramatically improved because you have fewer independent design intents. You have a master design intent, and that really is a great reason to use master model. You can imagine also, when we talk about design intent, what happens if you have a team of designers working, like for instance on a robotic arm, as is illustrated here. Each of them is left to his own devices to design their parts. And so those parts could take very different forms from each other. And what can happen, as in the example of this, you have something that looks very incongruent or disassociated visually, and maybe even functionally, when we talk about interference. So this is where a design is created with independent actuators and then put together. It looks something like this example. You can compare that to somebody who might have used a master model, as did Google here. I'm sure, I can't verify that, but I've worked with Google, and they probably did do that here. You can see the dramatic effect of using master model here, where you have a single design intent, and then that design intent drives every actuator. You have something that looks very integrated, very friendly, approachable, and I think that's the intent with their robot. You can imagine that those grills for the fans of those actuators, if you had to change the fan size, for instance, or the airflow, you could do that in the master without having to go to each of the individual parts and changing each independently. So how is master model implemented in SolidWorks? Well, we'll just briefly cover that. I've covered this extensively in those video webinar presentations I talked about earlier, but let's just review them. So in SolidWorks, you have various ways to implement the master model technique. One of the earliest and maybe often are arguably best used is insert part. And that's where you're basically creating a new part and then inserting the master as the first feature or close to the first feature in that part. And that allows you to have the master part as a reference to build your parts from. And you can see that in the diagram here, where you basically create a new part, empty part, insert a part into it, and now you have that part driving your individual part. The second method would be used that is become, well, it was implemented in around 2007, 2008, and improved in 2010, is saved bodies. Saved bodies is specifically made from the master model technique, and that is where there's an actual feature in the master or base part where towards the end of your multi-body part, you used saved bodies to derive out your bodies into their individual components. And I'll talk about the advantages and disadvantages of these three. There's also a split part, which is the ability to create a quilt or a surface body in your master model and then use that to split out various components. It can actually be used two ways, and I probably often more use it as for just splitting and not deriving out, but it's also built to derive out components. So with insert part, we dive a little deeper into each of these. The method is, like I had mentioned, you create a blank or a empty part, and then you insert a part into it. The advantage of this is that you can insert a surface or a solid, but you can also insert sketches, axes, planes, cosmetic features, whatnot, into the derived part. The added step, though, from this is that you have to actually, if you have a multi-body part from a master, you want to delete all of the bodies you're not going to use for that individual derived component. So you can do that, and usually the way this works is that you insert the part, and then the very next feature is to delete all the bodies you don't want to have as part of that derived component, or the delete keep body has the option to just keep that one body. So you can delete all the ones you're not going to use, or you can just keep the one that you're going to use. The disadvantage of this particular method, as I can see it, is you have to use the delete bodies feature, and because you're using that, it becomes how can I say, it becomes a little problematic. It's because SolidWorks doesn't well understand those bodies when they come in through insert part, and you can easily corrupt this feature, meaning that you have to go back in and reassign the correct body when something in the master changes. And usually it's in the master where you do a combine or subtract or a split or something that is going to lose the body ID. Once you do that and then you come back to the derived part, you'll find a lot of times that the delete bodies feature is in error, and you have to make that correction. So I'll talk a little bit more about the advantage of how to get around that. So you insert the part, and new for 2024, which I find pretty fascinating, is now you can not only insert a part, but you can also insert an assembly. Unlike before 2023, when you save that assembly as a part, in 2024 it actually stays associative to the original assembly. What I mean by that is that you, instead of inserting a part, you insert an assembly. It becomes a collection of bodies, And if any change is made to that assembly, those bodies will update in your master file. The only problem I find with this is that it's a little obscure to find. You would imagine that this in 2024, it would be in your part and it would be right underneath insert part. You'd see insert assembly. Well, it's not there. You actually have to do this from your assembly by going to the tools option in your current open assembly and then say make multi-body part. So if you're not finding that, go look in your assembly under tools, you'll find it there. So let's talk about the save bodies method over insert part. So the advantage of save bodies over insert part is that it is more reliable and more robust. What I mean by that is that it's kind of, you can think of it as less is more. So save bodies only saves out a solid body. And because it does that, I find it to be more reliable in keeping associativity to that body that's derived out from the master into the derived part. It also is been improved in 2010 to have a push-pull feature, meaning that if you have a derived part, and let's say, for instance, for some reason the derived part is the wrong body of your master, you can actually edit the stock feature now and go back to the master file it came from and reassign the body. You can not only do that, but you can actually go to a totally different master file and do the same thing. So it has a lot of versatility that way to correct errors. That's the pull method. The push method would be that you can actually edit the save bodies feature in your master and reassign bodies. And that's what makes it very powerful, is that it allows the author of the master to redirect the derived parts within the master file. With insert part, it's basically up to the derived part author to go and find the master and assign their own body. And this is what I'm talking about here with the push-pull method. It becomes a powerful and useful option to correcting any issues you might have with save bodies. And let's talk briefly about the third. Well, the split is also another way of using master model technique, and I find it very often less used than save bodies or insert part. But it does have the advantage over save bodies is that you can actually derive out a surface. So if you're from, like, maybe you have a Pro-E background, and you've been very used to doing a copy geom of surface quilts, this is probably one that you'll find attractive, because this is the way it works, where you can drive out surface or solid bodies and use those to cut up your parts in your derived part. How do I use it? Well, I'll use it occasionally where my master file is pretty much the part itself, and there's maybe one part that needs to be derived out. Let's say there's a battery door and it has like some feature, or let's say it's in a housing with a battery door, and the battery door is the only other part. Well, I'll use a split surface to just split out that part, and now I have component A, my housing, and B, my battery door. I think it's worth mentioning, though, also that there's other forms of master model, if you will. Actually, global variables are a way of doing master modeling. So in equations, you can actually set up a file that's globally sharing attributes. And I'll use this often when I have parameters that need to be shared amongst my parts. So maybe the sheet metal thickness or the shell thickness or the boss height or things of that nature. You can easily set up a text file in the same directory as your parts, and then use that, assign your equation variables to that file, and then easily reference those when you're building your parts. Very handy. So, there's one thing that I find kind of interesting, and I'm hoping maybe somebody has an answer to this, and that is external references. If you look at a derived part and you edit external references of a stock feature, you have the ability to break that feature. And that can be valuable sometimes where you don't want external parts driving or updating your master. That's especially useful for stock parts because by definition stock parts should never be changing. So if you want to break those references, you can, and you're really not going to be harmed because that stock part's never going to change, or it's not going to change very often. What I find interesting about this little dialogue here is that there's a checkbox that says insert features of original part if references are broken. Well, if you try that, and I have, and tried it various ways, I find that it's really not advertised as it's written there, because if you do that, all it does is it inserts the, like if you have a say bodies feature and you want to break the reference, all it does is it just breaks the reference, but all you see is a stock feature. There are no features from the original master model that are inserted into that derived part. And that's the way I take it when I read this. And it's somewhat disappointing that I've never seen this really work the way that I feel it's stated. Maybe that is technically the design intent, but it really isn't working the way that I would want it to do. If somebody has any more information about that, I would really like to know. So let's talk about best practices. And this is where I really want to get to in this presentation, as in addition to just talking about the advantages and disadvantages. So if you've heard any of my presentations on master model or surface modeling, you'll hear me over and over repeat the master model golden rule. And so the master model golden rule, if you're ever deciding what features you put into a master, this is how you settle that argument. It's basically the only features you put in the master are ones that are shared by two or more components. And likewise, features that are only shared by a single part don't necessarily belong in the master model. This is the logic that master model is built on, is that it's built to share features amongst parts. And if you have one part that maybe has a deboss of some text on it, and that's the only part that has that, you might want to think about doing that in the derived part, not in the master. So what's a list of some good practices? Well, again, above all, follow the master model golden rule. I find this often broken, and when it is, it's usually trouble follows. So really just try to hold to that. If you're not going to hold to any other best practices, hold to that one. I also find that there is some ambiguity on what, even if it is features shared between multiple parts, if that part is prismatic, very simple, maybe it could be created with a few features, maybe consider it not being included in the master model. Mechanisms and understructure that's very simple in its geometry, very few features, oftentimes I won't include it in the master model. I maybe will put a reference sketch to it, but I won't be building it in the master. So also, as you're creating your master part or master model, don't jump too quickly to building your assembly. Try to get most of your design intent in to your design, and then at a certain point you're going to find that, well, I've pretty much defined this, so now it's time to derive it out using insert or save bodies. Stock parts, very, very useful for inserting these into your master model to reference to. I do this all the time, and it is a good thing to do because, again, stock parts aren't going to change, so you don't have that danger of external parts updating and breaking your master. What you do want to do, though, is at the end of your tree, you want to probably delete those stock parts before you do save bodies, just to make it more clear that you never want to pass those stock parts through a master and then into your assembly. Maybe with the first rule, the fifth one is very important, and that is you want to plan out your strategy when you do master model, because it's being shared amongst many designers usually, and so you want to get everybody on the same page. Oftentimes when I counsel with companies, and this particular example was from a company that I did some mentoring with, where they went to the extreme with derived parts and master model, and it became a complete mess. And they called me in to do a day or two of mentoring with them to try to bring some logic and some sanity to it. And so we planned out what they needed to do and did this in front of the whole group and gained a better understanding of how it works and how it should be used and what to avoid. Even with Sarcos, I did the same thing. And I think what's particularly interesting about the reason we used it for Sarcos is if you look at the blue arrow to the right, probably the primary reason that we used master modeling with Sarcos is that they didn't have the skill set to do the advanced modeling. And we actually used an outside consultancy along with myself to do the advanced modeling and then have that drive all the derived parts. Basically, Sarcos' current process was everything in the gray rectangle. And then we added onto the top of it this master model approach. And it became pretty valuable. Everything was tracked in PDM and seemed to work out pretty well. So what are some of the things that you don't want to do? Well, one of the things that I find can lead to real danger is to be using the master model, but use it successively. And what I mean by that is to be able to create a master file, but then derive parts from it. But then on top of that derived part, you derive another part. And in essence, what you're doing is you're creating an insert part of an insert part of an insert part until you finally get to the final part in the assembly. Well, you can imagine how confusing this can be and why so many people object to it when groups don't use master model correctly, and they do this, it becomes a mess. And it also leads to more potential error, because when you have multiple derived parts on top of each other, it's just going to exponentially increase the amount of error that could occur. So what I recommend to groups, instead of doing this, do parallel masters. So if you have, like, for instance, if it's a robotic arm and there's a very simple circular reference between different actuator joints, use that circular joint or that sketch or that diameter and create the different actuators as their own master, deriving parts from those. It makes things more sane, and it's able to address that big problem I cited, where you have a large group of designers and they all need to work concurrently. Well, if you start breaking up into parallel masters, you're going to be able to do that more effectively. If you do need to have associativity from between parallel masters, a way to do that would be to create a master drive sketch. So a master drive sketch is a part, but it's just a part with very simple references in it. Say some sketches, planes, axes, and that master sketch drives the various master models. But if you're going to take this approach, what I would recommend not to do is to overburden that that master sketch file. This is an image from an actual client that I worked with where they did this. Actually, we did it at Spanner, and we soon learned how dangerous it can be. Where we took and we started adding, as we built up the product, we kept adding and adding sketch references and planes and whatnot to this master sketch. It became overwhelming to the point where you couldn't even navigate or find out what you had to actually change your derived parts or your masters. And this can be super problematic. So my recommendation, if you're going to use a master sketch, keep it as simple as possible. I would say, under 100, maybe even under 50 sketches or less, and keep it very sparse so that you can keep it organized and so it can be easily understood. The other thing about that is if you do create that master sketch, and let's say you use that as your master model technique. So you have various parts in your assembly and they're all being driven by master sketch. Well, there's a danger in that too, and that is if that's happening, what really can occur is that you're overburdening your assembly. Because think about it, if you have multiple parts that are all being driven by a common master sketch, all those, let's say those 25 references are being multiplied by each part in the assembly. And if the master sketch gets too big, you can get hundreds, if not thousands or tens of thousands of features in your assembly feature manager. It could be that you can't even really expand your feature manager because it takes so long to refresh all of those features. So just be aware of that. Now, if you're using a drive sketch or to drive master models, that's not an issue because remember the master model isolates those features from your assembly, that is your component parts. So keep that in mind. Now you might want to be asking, Mark, why don't I just do in-context assembly modeling like SolidWorks has advertised, where you have an assembly and you have parts in your assembly, but those parts are making reference to other parts in the assembly. This is a valid technique, but what I found over the 20 plus years of using SolidWorks is that it's not very scalable. And it's actually not scalable at all if you're talking about surface modeling. Surface modeling, the rebuild times are more for these kind of features. And if you consider what you're doing here when you're building in context of an assembly, what's called the top-down approach, is that any change in one part can affect all the other parts or many of the other parts. So what happens is if you build this way and you start making changes to your parts, you'll find that your rebuild times in your assembly are dramatically increased, and to the point where it's unbearable. And it's probably the reason why in the consumer products industry we don't use this approach. We use master model. So another good practice with master modeling, because you're creating a pretty complex part as a master, which contains many features, is you want to pay careful attention to organization. And when I create master models, I'm pretty freewheeling through most of the process of creating the design intent, but towards the end, when I start to organize it and want to save bodies or insert part, I'll go back and I'll organize my feature tree into features that are common to that quasi part. And I do a lot of reordering. If there's a feature or a fillet I created way down the tree and it belongs to some features close to the part up at the top of the tree, I'll reorder it. And it just makes it much better for multi-body master parts to do this, to organize in the end your tree into folders that represent the various features or usually the parts of the quasi parts that will be created. And it just makes it easier for yourself, but also for your associates that are going to maybe take over the authorship of your master model. So very important to do. And then you can see there at the very end, I do a remove ref bodies. So these are stock parts that I've used to design my master model. But towards the end, I don't want them to be included in the save bodies. And the way save bodies works actually is if you have any parts that are hidden or suppressed, they're not, and you initiate a save bodies, they're not included. Even if they're hidden, they're not included, which is by design intent. But I just find that a useful thing to do right before you do a save bodies is to just remove those stock parts from, excuse me, from your master file. And you do that using the delete bodies feature. So another important tip if you're using master model in your organization is to have everyone that's using SolidWorks in your organization and will potentially be building or working on derived parts from your master is to change this option in your system options. So you can find this under your tools options, system options, under external references. And the reason I mention this is because by default, this setting is set to change only. And this can be, excuse me, can be very dangerous because if you have someone working on a master model and it's derived between various other designers and that master is in the process of being changed, those changes will show up every time you open up a derived part and you have it at change only. And you don't want that. You want, as I mentioned before, the master to drive those derived parts, but do it intentionally. And so you probably want to set this to prompt or none for all of your designers and not to change only, or even change all, which is super dangerous. So just keep that in mind too. Make sure that your settings in your organization are set to parameters that work and are what everybody wants. And this is an important one when you're using master models. Another important thing to do, and this goes to the organization, is to name your bodies in your master so that they can be easily isolated and looked at by anybody coming into your master file, and they can be understood. So usually they are named per the quasi-component they're going to represent as a derive. And that's what I do here is I purposely change their names, and sometimes their names should stick. What you'll find for some of you that experience this where you keep building up and the names keep changing, those names keep changing on a few features where the feature itself, like a combine or a split, cannot understand what name to assign to the new body that's been split or combined. So it usually makes sense to really name these towards the end of your design process so that once everything is established and you do a save bodies or insert part, it's very clear what these bodies are representing as far as a component. Yeah, so I mentioned this before with save bodies, and it's the reason that's probably my preferred master model technique is that if things do go wrong, you have a way out with save bodies because you're able to go and edit from the derived part the body that should be correctly assigned to that derived part. You can do that by editing the stock feature in the derived part. You can also do it by editing the save bodies feature in the master part. And so there's a way to do this, and I have more information about this in the previous master model webinars that I did. Just another thing too is just be aware, this is kind of a minor issue, that the stock part name in your derived bodies or in your derived part, that name is not updated or associative to whatever it's pointing towards. It's really by design intent, because as you know, every name in your feature manager of a part can be renamed by the user. And this is probably why I don't argue with this. I think it should be updated. Like for instance, if you pull and go to a different stock part, it should reflect that name, but it doesn't. Just be aware of this, that if you're doing that and you're renaming your part, your master file, and especially if you're in a PDM system where you reassign it to a number or something, make sure that you update the name too in your derived part that is pointing to the right one. You'll see it actually, you'll see the difference here. If you do external references on that stock feature, you can see here that the actual part name is different from the stock name in your tree. So in summary, what I want to leave you with is, for you, now that you have a better understanding of the master model technique, consider using it in your workflow. Whether you're a consumer product designer or a machine designer doing mechanisms, think about it as being maybe a time saver and a more efficient and accurate way of modeling, or at least conceptually modeling. And then two, very important, always remember the golden rule of master model. Only features that are used in two or more components are in a master model. Those features that are only used in a single part or component don't belong in the master model. And then third, be organized in your master model approach. For yourself, consider not only yourself, but your colleagues. I mean, you're going to work on this master for quite a while. It's going to be quite a few features, and then you're going to go away. And for a few months, you might come back to it. And if you're not organized, you're not going to really understand it, even for yourself, let alone your colleagues. So a very important point. And I really strive to make my masters very understandable, and it'll pay off doing that. And finally, wouldn't you really want to work more efficiently? You could leave work earlier, have dinner with your family, and having this process really just makes you a better designer, more efficient designer, but gives you more time to do the other things that you want to do. As I mentioned, this presentation is not, I didn't bring up SolidWorks, didn't do any hands-on, but if you want to see that, you want to see a hands-on of how this is used and in more depth, I have two webcasts at the Spanner site that you can go to anytime and view them. They're about an hour long each, and there's also example model files that you can download and practice for yourself. Thanks for tuning in to today's episode. We hope what you've learned has been informative and can help you to better use some of SolidWorks' advanced features. You'll see in the YouTube description a link to example models used in today's video. Feel free to download it, and you can explore these techniques at your own leisure. Also, we'd love to hear from you, so consider emailing me at the address you see here on the screen. If you need help on your design project, or just want to know more about us, stop by our website at spannerpd.com or email us at hello@spannerpd.com. Take care, and I'll see you in the next episode.